So today we are moving on to lesson 4.2, combining functions algebraically. And the focus today is we will write equations of functions that are the sum, difference, product, or quotient of other functions. Then we will determine their domains and ranges. Just to recap, in the first lesson, we sketch graphs of functions that are the sum, difference, product, or quotient of two functions. So in the lesson we completed, the previous lesson, we looked at sketching the graph. And essentially we had two functions, and what is the third function when if we add those functions, or we subtract the function, or we multiply those two functions, or we divide the two functions. So we end up with a third function. So today our key math concept is a function can be written as a sum, difference, product, or quotient of other functions. The domain and range of the new functions is related to the domains and ranges of the original functions. So we'll go through a few examples and we will derive this basic proof. So when we're given two functions, in other words, g of x for x, f of x, and g of x, another function can be defined. So you can have another function if you add, subtract, multiply. Today I will give you 4 examples of combining functions algebraically. And at the end, you will be assigned 4 check your understanding questions from your textbook. So before I go into the examples, let's recap solving for f of x. And here are 3 examples, just to recap. And I know you've done this numerous times, but just to activate your algebraic skills. Here we give an f of x is 3 minus 4x plus 5x squared. Determine each value when f of x is 0. So I substitute 0 into my given function and to find the value for f of 0. So f of 0 is equal to 3 minus 4 times, since x is 0, times 0, plus 5 times 0 to the power 2. So f of 0 is 3. The next sphere we have f of, so we have this could be 3 minus 4 times 2 plus 5 2 to the power 2. So f of 2 is 3 minus 8 plus 4, 5 times 4 is 20. So f of 2 is equal to 15. And third one, we can solve it easily. So we have 3 minus 4 times minus 1 plus 5 minus 1 to the power 2. So f of minus 1 is equal to 3 plus 4 plus 5. So f of minus 1 is equal to 12. So we determine the value when we given f of x. So this is what we'll be proving today. Given two functions, f of x and g of x, another functions can be defined by adding, subtracting, or multiplying f of x and g of x. So let's look at three examples, and we'll derive that fact. So here I'm given three separate graphs. Now let's consider each one. In the first case here, we'll be adding functions. So here we have g of x, we have f of x and h of x. So it could be g of x plus f of x will give us h of x. So this, I'm looking at adding functions here. So here we have f of x, I'll write it behind there. Oops. So h of x is what we'll be adding, will be the third function. So you have g of x plus f of x. So let's consider h of x is equal to f of x plus g of x. So we can also write f of x plus g of x as we have for h of x is equal to f of x plus g of x. Now let's consider h of x of 2. So for f of x, so let's say h of x, let's select the x value is 2 here. So for h of 2, f of x in this case would be 2, because look at this point here, we have f of x, so x is 2, y is 2, so f of x is given us 2, plus g of x, so g of x is negative 1, so here's my point, g, when at the point when x is 2 at g of x, y is negative 1, so we have negative 1. So h of 2 will be equal to 1. So what's a domain? So the domain for f of x, if you look at f of x here, it's all of value where x is greater than or equal to negative 2. So x is greater than or equal to negative 2. We have g of x. So g of x, have it as the domain is, which is straight line. So x is a set of real numbers. And for h of x, if you look at h of x here, with x is greater than or equal to negative 2. Here we're subtracting functions, so we have h of, or like this d of x here. Let's consider d of x is equal to f of x minus g of x. So here we are subtracting functions. So we have f of x minus g of x, and we can write that as f minus g of x. So for d of x is equal to f of x minus g of x. So let's use d of 2. So f of x minus g of x. Now, if you look at f of x, f of x when x is 2, that is equal to 2. So write that here. F of x is 2 minus g of x when g of x, when g at g of x, when at the value 2, y is negative 1 is 3. So the domain are as follows for f of x. X is greater than or equal to negative 2. Here. For g of x, here we have g of x. It will be all of the real numbers. And for, because it's a straight line, and for d of x, it's where x is greater than or equal to negative 2. So let's look at the third example here. Multiplying, we'll be looking multiplying in this case. So we have d of, this is p of x. P of x is equal to g of x, or f of x, times g of x. So multiplying functions. So f of x, we can rewrite this f of x times g of x can be written as f times g of x. So p of x is equal to f of x times g of x. So let's take p of 2. So f of x, we look at f of x here when x is 2, and this point is 2, 2, 2. So we say it's 2 here. The y value is 2, multiplied by the g of x. When x is 2, y is negative 1. So it's a negative 1 here. So p of 2 is equal to negative 2. So if you look at our domain, for f of x is where x is greater than or equal to negative 2. So f of x negative 2 is greater than. So g of x, now in this case, g of x is a straight line. So we have all the real numbers. And p of x, now this graph starts from -2 and goes to infinity. So we say x is greater than or equal to -2. Now, what this shows us, if you look at all of the domains for each one of these adding, where we add the functions, subtract the functions, multiply the functions, we end up with a conclusion that the graphs, when you have two functions, f of x and g of x, are added, subtracted, or multiplied, the domains of a new function is a set of values of x that are common to the domain of f of x and g of x. So if you go back to these here, the domain for the composite function, h of x, it has to be a set of values that are between these two. So it cannot be less than -2. But g of x consists of all the real numbers. So h of x has to be greater than or equal to -2 because g of x contains all of the values, the real numbers. Same thing as the second one, subtracting the domain. And for the last one, it's the same for it. So that's why we can say when we have two functions are added, subtracted, or multiplied, the domain of a new function is a set of values of x that are common to domain. So there's a common to domain f of x and g of x. So once we know the domains of f of x and g of x, we can derive the domain of the composite function. So let's look at some examples. Example 1. So we're given the root of x and that's f of x, and g of x is x minus 3. And we're asked to state the domain and range of f of x and g of x. And given part B, given d of x is equal to f of x minus g of x, write an explicit equation for d of x and determines domain and range. And this third part, given f of x times g of x, which is equal to p of x, write an explicit equation for p of x and determine its range. So let's look at the first one. So we're looking at the domain of f of x and g of x. If you look at the square root of x, that graph, square root of x, the domain, if I could sketch, it's starting from the origin, moving to the right. So we say domain x is greater than or equal to 0, and the range also would be y greater or equal to 0. So for g of x is equal to x minus 3. Now this would be a straight line going through -3 and 3 here. So domain would be x, all the real numbers, and the range y set of real numbers. So let's look at part B. In part B, we're given d of x is equal to f of x minus g of x. So we substitute the values for f of x and g of x into our function. So f of x is root x, and g of x is x minus 3. So we end up with d of x is equal to root x minus x plus 3. Domain would be, in this case, where x is greater than or equal to 0, because it's the square root. As we know from the composite in the previous statement, the domain has to be greater than or equal to 0. So x is greater than or equal to 0 for d of x. Now the range, you will have to use a graphing calculator. And if you use a graphing calculator, you'll find that the range is from anything where y is less than or equal to 3.25. Okay, let's go to the last part, part C. I'll have to use some more paper here. I'll use so let's look at C. So we have P of x is equal to f of x times g of x. So P of x is equal to the root x multiply, let's put a bracket around these, make it look minus 3. So since our domain has to be greater than or equal to 0, and this is a straight line, x is all the real numbers, for domain x is greater than or equal to 0. Now, you'll have to use your calculator to find the range has to be y is greater than or equal to negative 2. Okay, let's go on to the next question example, example 2. Okay, example 2. Now we're looking at a quotient. Writing the equation of a function that is a quotient of a function. So similar to the first one, so part A, we can state the domain and range for these. So if you look back to what we did earlier, for the as we sketched the graph of square root of x, and for x minus 3 to the power 2 be going up here. So the domain for f of x will be x greater than or equal to 0. And the range where y is greater than or equal to 0. Now for g of x, if you look at g of x, which is this graph here, so the domain g of x, which will be all the real numbers because this graph goes negative infinity to infinity, and the range of g of x would be y is greater than or equal to 0. Part B, you're asked to write an explicit equation for q of x, then determine its domain and range. So we're given q of x, so we'll write this down, q of x is equal to f of x over g of x. So we'll substitute x is equal to f of x, and we have x minus 3 squared is equal to g of x into a given function. So q of x is equal to the root of x over x minus 3 squared. Notice that for the domain, in this case, the domain where q of x has to be greater than or equal to 0, because it will be undefined if it's less than, greater than or equal to 0, and where x is not equal to 3. So the domain x has to be greater than or equal to 0. Because if you look at our function here, this is your previous one. So domain is from greater than or equal to 0. But also, it's undefined where x is, in this case, 3, because it will be 0 as a denominator. So x cannot be, and x cannot be 3. So the range, we'll have to use a graphic calculator for this one here, and you'll find that the range is y is greater than or equal to 0. So to recap, to write an explicit equation, when we given a quotient, we substitute what's given for f of x and g of x into our function. And this is our explicit equation. Let's look at the third example. In the third example, we have to consider the function x squared minus 2x plus 3, and we are to write an explicit equation for three functions f of x, g of x, and n of x, so that h of x is equal to f of x plus g of x plus n of x. Now, there are multiple answers for this example, and I'll show you one possible or two possible answers for A. And then it has to write explicit equation for two functions f of x and g of x, so that h of x is equal to f of x minus g of x. Let's look at part A. So in part A, we'll just rewrite our formula down. We have h of x is equal to x squared minus 2x plus 3. So there are more one possible answers. Actually, more than one possible correct results. Okay. See more than one possible correct answers. Okay. So one possible sum would be, now here what we have, we want f of x plus g of x. So if we make this as f of x, and we can also make this of g of x, and this would be like n of x. So we can say f of x is equal to x squared, g of x is equal to negative 2x, and n of x is equal to 3. So if we could rewrite this as a function of h of x is equal to x squared plus minus 2x plus 3. So this is your f of x plus g of x plus n of x. So here we have f of x times minus g of x. So we have h of x is equal to 4 h of x is x squared minus 2x plus 3. So we need f of h of x is equal to f of x minus g of x. Now, we have to change this function around so that we can end up with f of x minus g of x, and it will still maintain its original function. So if I make f of x, in this case, as x squared, say this would be x squared. So let me make this as f of x. Then I have to make the entire 2x plus 3 as g of x, but I need to, because I have a negative sign, I have to change this into a negative to make it valid. So this becomes g of x. So we write f of x is equal to x squared. So g of x will be 2x minus 3. So we can write this as x squared minus 2x minus 3. So this is my f of x, and this is my g of x. And it will satisfy, you just notice it doesn't change the original function. X squared minus 2x, minus and minus is plus. So it's x still maintain x squared minus 2x plus 3. Okay, let's look at the final example. Example 4. In part A, you're asked to find or write explicit equations for two functions f of x and g of x so that p of x is f of x times g of x. So I'll rewrite A. So I have p of x is equal to x squared minus 2x minus 8. So I'll need p of x to change this into p of x is equal to f of x times g of x. So the easiest way to do it is to factor this polynomial or this trinomial. By factoring it, I end up with two binomials, and that will satisfy this. So if I were to factor these, so I take this, so I get x squared minus 2x minus 8 to factor it. So the x and x. So we have the factors of level 4 and 2. So we have, in this case, we have negative 4. And over here we have plus 2. So this could be our f of x, and this is our g of x. So p of x will be written as x minus 4, or it doesn't matter, or x plus 2, and x plus 1, 2. Now, the second part, okay, the line across here, hopefully I have enough function f of x and g of x, so q of x is f of x divided by g of x. So the domain, if you look at this part here, given q of x equal negative x minus 4. So x minus 4 must be equal to whatever you have f of x over g of x. So what we know from this that g of x cannot be equal to 0. So to choose, for example, we have x squared. The only one of the few things could be x plus 4, x plus 2. Anything will not give you a non-permissible value here. So let's go to the next one here. We have b. So q of x is equal to x minus 4. And we're asked to write explicit equations for two functions. So q of x is equal to f of x over g of x. So we know the domain for q of x, x minus 4 is all the real numbers. So we know domain for q of x, x minus 4. This is an equation of a straight line. But the domain for f of x, right, and g of x must be real, but g of x cannot be equal to 0. In this case here, g of x cannot be equal to 0, or else it'll become non-permissible. It's undefined. So I'll choose for g of x x squared plus 4. Now you could have chosen x squared plus 2, x squared plus 1, because there is no non-permissible here. When you have x squared plus 4 as your denominator. So next I'll do, I multiply g of x by x minus 4. So that will be x squared plus 4 multiplied by x minus 4. And this would give me x cubed minus 4x squared plus 4x minus 16. So finally, I could write q of x is equal to x cubed minus 4x squared plus 4x minus 16 divided by my non-permissible that I chose here, which is x squared plus 4. Okay, so that's it for examples. Your task next is to work on exercise 3, question 3, 4, 5 on page 278 of your textbook, and 6 and 7. Questions 8 and 9, and 15 and 16. So recap your assignments. And for your textbook, question 3, 4, and 5, 6 and 7, 8 and 9, 15 and 16.